This is Lab 5, Analyzing Pendulum Motion by James Ashwell. In this lab, I analyzed data and video observing a mass in an oscillatory pendulum situation, suspended by a rope and influenced by the force of gravity and the drag force. The purpose of this lab is to showcase our physics knowledge that we have accumulated throughout the course and to create a unique scenario to apply our knowledge. Some underlying physics principles are understanding different energy graphs and how to calculate various types of energies, and using the position update formula to update information about an object's motion. As a preview of the results, the tracker analysis of the pendulum yielded slightly different results, primarily to drag acting on the real mass and other sources of error. And the computational model of the situation correctly modeled an energy versus time graph of the tracker data. Here's the setup of the experiment. The system is the mass, rope, and earth, while the surroundings are everything else. For the initial conditions, the mass was released at the top of the pendulum's arc, and it began to oscillate back and forth. For the coding portion of the experiment, I took code from other labs to set up a visual to represent the data from the tracker analysis and to create a graph of energy versus time. I also utilized principles of torque, angular momentum, and the cross product to predict the mass's motion and energies over time. Finally, I updated position every time step via the position update formula. Furthermore, this is the output from running the code from Web Python. It demonstrates an oscillatory pattern of motion for the mass in both the x and y directions. The total energy of the system remains constant, and all other energies also exhibit an oscillatory pattern. There are slight deviations between the tracker analysis of the mass's motion compared to the computational model due to different sources of error, which I will discuss. Here are some possible sources of error. Firstly, a recording error by having possible misclicks on tracker analysis and not adjusting frames correctly at the beginning and end of the video, causing the experimental model to be slightly off from exactly matching predicted data. Furthermore, I could have made mathematical miscalculations in calculating the initial position and velocity, which would alter the predicted data from the computational model. Also, the force of drag accounts for the pendulum path to be slightly off from the actual mass's motion. What does it mean? Is the energy principle satisfied? Yes, because there is no work being done externally on our system. The total change in energy throughout should be 0, which it is. So, what if the pendulum was placed in a vacuum and there was no friction elsewhere? Because this eliminates the force of drag on the mass due to the loss of air resistance, the mass will enter a state of perpetual motion and will oscillate forever. In conclusion, a mass attached to a pendulum experiences oscillatory motion in both its position graphs and energy graphs, and oscillatory motion can be predicted very accurately using computational models. Thank you.